Here we have exercise 4. We have a third degree function again here. And here we have the graph. The graph of f crosses the y-axis at the point P. The line L is tangent to the graph of f at P. Find the derivative. So that should be fine, I hope. Exercise A here, find the derivative. And then question B here is find the equation of L in terms of A. And remember, if you want to find the equation of a tangent, we could use the point gradient formula, which looks like, use M in English. This is the letter M. This is the point gradient formula, or ettpunktsformelen in Norwegian. So we have to know three things. We have to know x1, we have to know y1, and we have to know the slope m, stigningstallet m. We know that x1, the point P here, of course, has x coordinate 0, and the y coordinate is the constant term 6. So x is equals to 0, y is equals to 6. And the gradient, to find the gradient of this slope, we can use the derivative. That's exactly what the derivative gives us. It gives us the slope of the tangent in a point. So if I put 0 into the derivative, I will get an answer here if you do this, and this will be the gradient, the slope of the tangent. So calculate this and you get a number, and this is then m, and you put and you get y minus y1 equals to m, which I haven't calculated, so you have to do that on your own, but m here should be a number, times x minus x1, which is 0. So you get y minus 6 is equals to m times x, and you just put 6 over, and you get mx plus 6. So, but of course, m here is a number which you calculate by calculating this. So then you have the equation of the tangent line, and in exercise 4c, the graph of SF has a local minimum point at Q. The line will pass through Q like this, and then you should find the value of A. Of course, when you calculate this, I said you should get a number here, but you should get an expression with A here, something like A, or 2A, or 4A, I don't know, anything. Yes, so there's an A in here somewhere, right? So, and you should find this A by this information here, and yes, so there's two things here that you know that this is a minimum point, which means that you know that this is equals to 0. And so you have to solve this equation in some way. And the other thing you know is that yes, there's different ways of doing this, but if you call the x coordinate here for example b, right, like this, you know that f of b is equals to 0, and then you will get an equation with both a and b. So we have two unknowns and you just have one equation, so we have to put up another equation as well, and you actually know that when x is the number b, then this will be equal to this, and here I write g of b, and then I mean this function here, let's call it g of x, right? M should be something with a here, as I mentioned, but if you want to find the intersection of 2 points of two graphs, you have to put them equals to each other. If you put two functions equals to each other, let's say f is this function and g is the tangent line, if you put them equal to each other, you should get the intersection points. You should get two solutions. The one is P and the other is Q, and So you know that this will be the case. When x is equals to b, this should be equal. This was a horrible explanation, but take it as a challenge and try to solve this. So you should get two equations here with two unknowns, and you should then find, and the two unknowns is a and b, and you should be able to find a. I'll just say good luck with that. Okay, that was exercise 4.